The following is brought to you by Total Seal Piston Rings, the leader in ring seal technology. TotalSeal.com. Hello and welcome to Hidden Horsepower by Total Seal. I'm Joe Castello, and I'm very excited to do another show where we dive in to the world of high-performance piston rings with the Director of Technical Sales at Total Seal, Mr. Keith Jones, who joins us now. Keith, welcome back.
Thanks for having me, and I want to wish everybody a great new year. It's off to a great start. It's busy as heck, and a lot of the country I'm looking at some pretty decent weather right now, so hopefully everybody's enjoying a nice, mild winter.
We want everybody to be able to listen to these shows whenever they want. It could be a month in the future or 10 years in the future and still gain worthwhile knowledge. But the fact of the matter is everybody is getting ready for the racing season, and that means you have to work extra hard in your job.
Yeah, we're putting in the overtime right at the moment. I'll tell you that. If phones are ringing off the wall, we love it. We love fielding all the questions from customers. Everybody's specking new projects, what they're doing, what they think we need, for the best ring combination to have the best results out of their package. So yeah, it's a busy time here, that's for sure.
We encourage everybody to subscribe, Apple Podcasts, Spotify, wherever you get your podcast. You can listen to Hidden Horsepower by Total Seal. And the first few episodes have been very well received, and we've had like engine building superstars like Jason Line and Pat Musey. We had a Pro Mod world champion, Stevie Fast Jackson, and of course, Matt Hartford himself. This episode, we're going to go in a slightly different direction. We're going to have Ben Strader from EFI University, which, how would you label him, Keith? Like, my knowledge is, engine scientist, right? Somebody who is not only educating future engine builders, but also just kind of trying to push the edges of what's possible in competition engine development.
Yeah, absolutely, and not trying to inflate it in any way. And Ben will probably laugh at this. I'll call him the big brain in a head. Ben's a super sharp guy. He's a good friend of the company, and just a great all around guy, and an incredible thinker. Ben's always trying to think outside of the box. Always trying to face that challenge, whatever it is, whether it's a fuel injection problem or a valve train problem. Ben, networks and works with everybody to fight, find these, the solutions to the challenges that present us. And, a perfect example is his spinal tap project, trying to take this engine over at 11,000 RPM. This is an amazing feat. But Ben, met that challenge head on and tackled it and did it. And it's awesome. He's like I say, a super incredible guy, and nobody that I know of, that I've ever met knows more about fuel injection than Ben. And you can stop me anytime you want. But fantastic guy. Anybody, I'm giving his school the plug right now, but anybody that's interested in knowing about these things, advanced engine building, electronic fuel injection, you really need to check out EFI University. These guys have got a program that's second to none.
And I first became aware of Ben when the NHRA made the switch from carburetors, the ancient technology, to fuel injection, and I was able to speak with him on one of the other podcasts that I do, and obviously he is a great communicator, and let's not keep him off the air for much longer. Joining us now from EFI University, Mr. Ben Strader. Ben, welcome to Hidden Horsepower. How are you?
Hey, thanks, guys. I'm doing great. Thanks for having me on your show. I feel super underqualified compared to the other superstars you've had on there, but I'll try not to be too boring and let you guys down. But thanks for having me.
Well, it all depends on who you're asking, right? There are people who want to see cars who go fast, and there are fans, there are like hardcore engine builders or people that follow that. They want to know what's going on in valve trains, and that was the whole point of your project Spinal Tap, to do something that seemed impossible.
Yeah, we actually just finished that project. It took almost 3 years to get it to do that, but just finished it about, I don't know, maybe a month or so, a little before, after Thanksgiving, before Christmas, somewhere in that time frame. Maybe it was before Thanksgiving, but not very long ago. And man, I'll tell you, if somebody ever says, like, how hard could it be, and you say, hold my beer, like, just stop there, because, it was way harder than I ever imagined it would be, because everybody seems to go like, oh, it's just 11,000 RPM, like no big deal. Yeah, well, do it with an inch of lift, or in our case, an inch 050 of total valve lift. And remember, you're trying to open that valve 93 or 94 times a second and make it all live. So it was no small feat, and I'm super proud that we did that.
And Keith, what Ben does, what he did, to be honest, I just kind of watched all of the Project Spinal Tap videos and stories all in a binge, right? I'm binge watching all of it. To come up with a concept like that, it's not too dissimilar to what many racers are out there doing, like trying to come up with the next thing that's going to work well. And you guys at Total Seal, you communicate with people like that all the time. What did you think about what they were trying to do, go 11,000 RPM with an LS-style engine?
Oh, like I say, absolutely, knock my socks off, because I can't say, nobody's ever done it before, because I don't know everybody, but to my knowledge, no one's ever done that before. And, the challenges that were put before Ben and the guys, were just, not to say insurmountable, but I'm sure there were times where they thought they were, because, getting something to turn a lot of RPM one time, hey, you can do that. There's a lot of things in my world that's like, hey, yeah, it'll do it once, but to do it over and over and over and have it hold up and stay together, that's truly the challenge. And we work with people like that every day, from drag racers to, NASCAR style applications, trying to get, to do this. And that's one of the big things in the world today, is we all want to get longer life out of these parts, and to do this successfully and get an engine that does this repeatedly over and over and over, it's like you say, it's quite the challenge. You get to do it once or twice, not to say it's easy, because it's not, but to get it to do it 200 times, that's a whole nother thing. And again, tip of my hat to Ben.
So I appreciate that. There's more to it than that, though. I think a lot of people have said, like, I don't see what the big deal is. Lots of engines have done that before. Pro Stock guys did it, blah, blah, blah. And that's all true. But I don't think a lot of people understand what the limitation is when we start talking about, we did it with an LS7 engine. So when you start looking at the cylinder head on an LS-based engine, especially like a stockish layout, they're all inline valves, and it's a very narrow cylinder head. So the problem is that a lot of people understand the concept of rocker arm ratio. You move the one side this far and the other side moves that far, and that's all well and good, but not a lot of people that I run into in our classes understand what rocker pivot length is. And so that is essentially the distance from the trunnion on the rocker arm to the valve tip, where the roller is on the tip. So the ratio is simply the difference between the pivot length there and then the length behind where your pushrod is. Well, because the LS cylinder head is so narrow, you cannot get a long pivot length on a rocker arm. And that's a huge disadvantage when you're trying to do a lot of lift, because the rocker arm tip, where the roller is, it actually travels in an arc, like a circular path, but the valve tip is traveling straight up and down. So if you can make that arm really long, like you can on a big Hemi engine or a DRCE or something like that, the amount of horizontal travel in the geometry, the sweep that you're getting through that, let's say, 1 inch of lift up and down, is a lot less. Because if you just draw a big circle with your arm, you can see that the horizontal distance the rocker tip moves is way less for the same 1 inch of movement than if you have a little tiny short arm, right? So when I tell people we did it with an LS, they're like, oh, that's no big deal. Lots of guys have done that before. And I'm like, not a lot of guys have done it on a super short inch 550 pivot length, narrow cylinder head. Like, you literally can't fit a longer rocker arm in that head. So it was a giant challenge to get that engine to do it.
To say, Pro Stock's done that and this engine's done that, it is the challenges of dealing with a package that was never, ever intended to do that. When you've got clean sheet of paper engines, the DRCE engine, not to say completely clean sheet, it had some parameters to work around, but, the current NASCAR-style platforms, when you're dealing with a clean sheet of paper engine, as Ben just stated, you can design everything to fit perfectly. You can design, where the camshaft sits in the engine so we can get shorter push rod areas. We can design the pivot area in the rocker, in the cylinder head. We can work around all these things, or not work around, correct these things through design. Ben's dealing with an engine that was designed for General Motors needs, not for Ben's needs, and he's done all the engineering and work to make it what he wants it to be versus what they wanted it to be. And that's, again, a tremendous challenge that a lot of people don't realize.
Right, and so keep in mind that getting the valve train to live was only like a third of the total problem, right? So there was 3 major obstacles. One was getting a valve train that would live. The second one was coming up with an intake manifold that would work, but I'll explain in a minute why I feel like we're at the cutting edge of that technology right now. But the third was, getting a short block that would live, and specifically, you'll remember I called you, Keith, way back in the beginning of this project, and we talked about rings because the amount of friction that you get as the engine speed goes up is exponential. It's not linear, you know what I mean? Because you get, so the ring package had to be just right, and small, low tension, low friction rings, and then oil control and cylinder wall finish. Everything had to work to be able to get up there with that kind of RPM without ripping the skirts off the piston. But the point that I want to make is if you look at, as you said, a clean sheet engine like a DRCE or a NASCAR block or whatever, the intake manifold on a Pro Stock, they typically have extremely short runners. And the reason for that is that they have to be. In order to achieve peak power at those big RPMs, there's a pressure wave that travels back and forth in the engine from the intake valve when it closes back out to the plenum, and then it turns around and goes back the other way. And so the goal is to time the events at a specific RPM so that strong wave of pressure is getting back into the cylinder the next time the valve is open. So as you can imagine, depending on what your RPM is, the amount of time that the valve closes and then actually opens again is an easily calculable number, right? So what they try to do is they try to make the runner length the right distance for when the intake valve closes, that pressure wave goes back to the plenum, and then it comes back to the engine. Well, the higher your RPM gets, the faster that's happening, so the shorter that distance needs to be. Now, the problem with a V engine is as you make the runner length short, your plenum has to get wider and wider and wider to be able to connect the two sides of the engine. Well, when they had carburetors, when the plenums got really big, the cars wouldn't accelerate down the track because it would lose the signal to the booster venturis in the carburetors. So for about 5 or 6 years now, I've been on this mission to sort of prove that we don't have to have the super short block deck heights that like a Pro Stock engine has because we're using EFI, and we don't need to have a booster venturi signal. And so a lot of the Pro Stock guys that are doing EFI now have been saying, hey, we've noticed these engines don't seem to be as sensitive to plenum volume as they used to be. And I'm going, that's what I've been saying. So on the Spinal Tap project, we used EFI throttle bodies up on the top of the engine like a carburetor. And we've got this giant box plenum and, correctly short-sized runners. And you know what? The thing runs fantastically. And so we're just in this sort of state right now. We're doing a ton of research on plenum volume and runner shape and length and all that kind of stuff. But what we're seeing is now that we don't have carburetors, we can have a lot more flexibility in the engine design than we didn't used to have.
Keith?
Yeah, what he said. No, absolutely, and I agree with everything you just said because carburetors present their own challenges, and and it's funny. I've been a carburetor guy for years, and what Ben was just talking about, keeping the speed, the velocity up inside the intake manifold and through the intake tract to signal that booster. That was in my days of doing all this type of work was always the thing. People would talk about, runner volumes and runner lengths and, how much air can it move, but how quickly can it move it? What's the velocity like? We have to keep the air speeds up high to make the carburetor do its job. And as Ben just said, and he is the expert, this is the beauty of electronic fuel injection or fuel injection in general. We're not relying on that anymore. We still got, we still want to keep the speeds up, but we're not relying on that to make the carburetor do what the carburetor does. The fuel injection is there to do it for us, and it's amazing. It really truly blows my mind, as with the conversation with Pat on the Pro Mod stuff that he's doing with what we're able to achieve with the fuel injection these days. It's amazing. And as Ben mentioned with the RPM levels of the engine, looking at ring weights and ring tensions, because as he stated, the friction's exponential. It's not linear, so we have to consider that RPM. What we can do at 9,000 RPM in a ring package is not necessarily what we can do at 11,000 RPM. We have to look at the masses, right. What ring reversal, top and bottom dead center, the forces that we're dealing with there that are literally trying to rip the rings and the pistons apart. It really becomes a big part of the package at that RPM, and it's a very important consideration.
Only a couple of years ago, we were going, we got this little 043 ring, and it's pretty small and sexy and racy, and that would never fly in an engine like this anymore. I mean, we're almost half that, not quite, but almost half that, what we used to think was a small ring.
kind of like we said before, there's the difference between turning 11,000 once or twice or doing it over and over and over. And one of the differences.
And anybody can do 11,000 once. Just push the clutch in when you're still on the floor with the throttle,
There you go. And
there you go.
This project was, kind of like a moonshot in many ways. How would the rings have been different if you're going for longevity and max horsepower as opposed to just try to achieve a number, or did you build it that way? And tell me a little bit about when Ben first called you and said, this is what we want to do.
Yeah. They kind of go hand in hand. I'll be honest with you. From my perspective, I don't ever approach a ring package as being a sacrificial part, that it's only got to go once or twice to see a number. That really doesn't enter my thoughts. I want to provide a package that's going to do what he needed to do consistently, repeatedly. Could we have done an incredibly, what I'll call ultra thin, less than a 0.5 millimeter? It certainly is possible, and could it have worked once or twice? But that really isn't a consideration for me. I want to give him the thinnest, lightest, lowest drag parts possible, but at the same time knowing that he's going to be really running this thing. They're going to be running all kinds of parts through it, cycling different things through it. They don't want a ring package that they have to, pull this thing apart every 5 or 6 pulls. It's got to go the duration. So that's always part of my thought process is, giving him the most reliable package, but at the same time, the best possible performance. So the thinnest, lightest package within the parameters of what they're going to use the engine for.
And Keith, along the way, we talked a lot about different kinds of coatings and like barrel face versus taper versus all that. So talk to the guys out there that are interested in the engine technology about what are some of the different coatings available? What do they do? Why would you want them? I think that's a good thing for you to share, if you don't mind.
Yeah, absolutely. We offer a fairly long list of coatings, and as Ben just indicated, it kind of comes down to what your end game is here. And we have different coatings, ranging from what I'll call the old school coatings, molybdenum and hard chromes that are kind of more, mild performance street type applications, diesel applications, more what I'll call long-term longevity coatings. Again, older school type of coatings. But then we've progressed many years ago and really gotten into quite a list now of PVD type coatings, which are PVD, physical vapor deposition. These are done in a vacuum chamber. Thin film technology. If you Google those words, you'll see all kinds. And we offer coatings that range from tungsten carbide carbon to chrome nitride to titanium nitride to diamond-like carbon. And as we go up that chain, we're increasing the hardness of the coating. So what we're looking at is durability, longevity, and coefficient of friction. What type of cylinder materials are we working with? What type of oils are we working with? Is it a high vacuum condition? Is it a low vacuum condition or a no vacuum condition? So that's where the coatings come into play and why we stress so often to call us and talk to us about what you're doing, because rarely is there a one-thing-fits-all product out there. There are products you can put in and it will do very well, but is it really the best for what you're doing? So generally, again, in an application like Ben's, we're going to look for a harder coating, something like a titanium nitride. We want to get a lot of longevity, a lot of life out of this part, something that's going to wear very well, has a low coefficient of friction. And as I stated, there's kind of a few selections there. And then we also do different types of profiles in the face, barrel faces, offset barrel faces, where the barrel's kind of shifted to one side or the other depending on the customer's needs. This comes down to point loading on the ring, how much unit pressure it puts onto the cylinder wall, also into how much rock over the piston has. Does it have a lot of rock or a little bit of rock? We can tune the face profiles depending on how much rock over the piston has. And that's just in the top rings. Second rings, we can do tapered faces, Napier faces. There's kind of a list of face profiles that we'll do on the second ring. Again, we try to, we have profiles that work well as general applications, but we do try to and want to speak to the customer to tell me what you're doing, tell us about it, and that way we can make sure you get the best possible package for what you're doing.
I'd say that's probably the biggest piece of advice that you could give any newbie or even older, especially probably some of the older engine builders that have been doing it a certain way for a long time. This is just what we do and it's what we know. If you wanted to make advancements and strides today to improve your program, probably the best thing a guy could do is stop just going to page 37 in the catalog and picking whatever ring's there and call, Keith or Kevin or one of the guys over there and say, what do you got that's special to do what I'm doing? And man, there's a lot of power, reliability. There's a lot going on in rings that gets glossed over by guys that go, no, you just stick the same old thing in there. And man, the technology has moved way too far these days to still be using John Deere tractor stuff,
Absolutely. And
isn't that the truth?
But how would you know, right? And it's hard enough
you wouldn't. There's no way you would know.
To keep your business going, to clients coming in, coming out, you do what you've done. It's always worked. Not everybody has an R&D department to go out and figure out what the new latest, greatest thing is. That's why you gotta listen to this.
Well, and I'll tell you, Joe, like you're touching on something that's kind of near and dear to my heart, and that is I'm of the opinion that most engine shops out there, most engine builders, engine shops, whatever, they don't do any research and development per se, meaning most, and for obvious and good reasons, most shops today, the R&D is reach and dial, right? Pick up the phone, call the guy that knows, buy the right stuff. And there's nothing wrong with that. In fact, it's a necessary evil to stay in business and make a profit and whatever. But that's why we need guys like the Keith and the guys at Total Seal. But I think that's what makes my business different too, in that I don't consider us an engine shop. I don't even consider myself an engine builder, even though I got a cool award as Engine Builder of the Year, last year at the ATEC deal, and that's all great. But I don't see myself as an engine builder because, frankly, I don't have much in the way of customers. We build stuff solely for the purpose of learning and research and development, and it's like it's okay if this doesn't work because then we're going to learn what doesn't work too. Whereas I think what happens with engine shops is they're not in a position where they can afford to try something that might not work. They can't afford it from delays to delivering the engine to the customer. They can't afford it for a customer that maybe doesn't win a race or, God forbid, an engine fails. And so they get stuck in this like stagnant, cycle of building the same stuff all the time because of this fear of the unknown. And that's where guys like me and Keith and these guys that are doing the cutting edge stuff isn't so that I can look cool or feel good about myself. It's so that we can cut down the amount of risk that an engine shop has in trying to improve their program through getting better products without the risk of the R&D. And so I consider myself more of an R&D guy than a true engine builder.
So where is it all going? We know where we are and that we're being overwhelmed by technology, and people are figuring ways to apply this technology, as you just have done. But what have you learned through this project that tells you about where things are going to be in the future?
Well, I think there was a whole bunch of fronts on this project that I personally learned a lot about. I mean, I started this project really, you don't know what you don't know, right? So you think you know everything, you think you're pretty smart, and then you start doing something and you get smacked in the face a couple times and so along the way, we started this project 3 years ago, going back and forth on a plane to Memphis, Tennessee, to use the Spintron at Comp Cams to try to work on the valve train. And it didn't take very long before I realized, first of all, there's a whole entire other universe out there that I didn't even know that I didn't know about in the development of a valve train. So we need more time on the Spintron, and of course that's hard to just get. I don't know where you go to say, hey, can I borrow your Spintron? Even a place like Comp Cams has their own work to be doing. So we ended up buying one from the guys at Trend, and so we now have our own Spintron here in-house that I think the advancements that we've made in 3 years here alone, not considering the benefit that Comp Cams got from helping us with it too. I mean, they've got probably 100 new Loeb family designs that they're currently selling in their catalog that were kind of birthed through some of that initial research and honestly failures and successes that we eventually had. So I think as far as us V8 drag race, roundy round push rod guys, I think valve train developments are huge. And I think for me, again, only 4 or 5 years ago, we were using, 043 quote unquote badass racy type rings that we thought were cool, and we didn't even know any better. And to be 100% honest, I got exposed to a lot of that stuff when I was working on the Pro Stock stuff. And then when I was finished with that and we came here to work on our program, I went straight to the guys at Total Seal and Keith specifically, and we started going down that path. And so I think airflow has always been the main goal of an engine, but there's only so much airflow a guy can get. So the rest of it is, well, I can make, so much combustion, so much power, whatever with this airflow. Now I got to figure out how to keep it. And that means controlling my valve train. That means sealing the cylinder. That means reducing friction and capturing the heat that we were losing before. And so we're nowhere near done. We're nowhere near making as much power as we can make, and we're nowhere near reaching the levels of reliability that we think we can get. But man, we're a lot farther than we were 3 or 4 years ago.
Boy, isn't that the truth? Yeah, I gotta back up everything Ben just said. One of the things that I find in this industry, and I think we see it in every aspect, from whether it's a piston ring or a camshaft or a crankshaft, any of the part, there's so many accepted rules in our industry that this is how you do it, or preconceived notions that you can't do that, you can't turn that engine 11,000 RPM. Well, why can't I? Well, because you can't. Well, who said? Well, they said. Well, who is they? And there's just so many of those roadblocks that are out there through preconceived notions. I mean, again, 10 years ago, you can't run a 20,000 stick. Why? Well, because it won't hold up. Well, guess what? We've proved otherwise. We've accepted for years that gas ports and pistons are the only place to put them. Well, our new gas ported top rings has proved that differently. The new, our total conforming, we're constantly being pushed for more. We reach the limits of the part that we've produced. Why do we have a 20,000 stick ring? Because we reached the limits of what an 043 ring could produce. That was the norm for X amount of years. And they always want more. They never come to your door and say, you know what? Can you knock about 20 horsepower out of my stuff? It just makes too much power. It never happens. We could tone that down just a touch. They never come at us with that. They always want more. And once we hit the limit of that, what is we accept as the best of the best, we have to find the next level, because we're always pushing this. And whether it's valve train or fuel injection design, from my side, accepted ring materials, we're pushing the boundaries on new types of ring materials so that we can make them thinner, even more lighter, move heat better out of the piston, because heat is the enemy. And then coating technologies, we're always exploring new coatings, looking for the next newer thing, the next better thing, to help fix the issues that are out there now: micro welding, wear, reducing friction. We're just constantly pushing it. So that's one of the challenges. I don't mean to keep going on about the same thing, but that's one of the biggest challenges. Is we can't accept that this is what it is and that's as far as we can go with it, because we can always do more.
I'll tell you what I think the biggest change across the industry is, Joe, to kind of answer your initial question about where do we see it all going. And that is what's happening right here today on your podcast, and on, like, for example, what you did all last season with Matt Hartford. The difference is, there was always guys in closed door shops, the classic old, WJ, Warren Johnson, cameras come to the door and then he's got his arms folded. Nobody comes in the shop and it's all super top secret. And there was always guys doing this level of research. The difference is today, now we're telling people about it. So, 2 months after we accomplished something that had never been done, we're telling everybody that we did it, how they can do it. You're sharing stuff on this podcast. We're sharing stuff at our school and our podcast. You guys are doing stuff in Pro Stock that's never in a million years people thought they would get to see. And I think that's where the future is we got to build from the ground up the next generation of engine builders and racers. And when you ask me where I think it's all going, I think it's all going towards a community and sharing information rather than keeping it and hiding it and sort of like, because it's discouraging for the guy coming up. Well, I'll never get to that Warren Johnson level, so I'm not even going to try. And so now everybody goes, well, shoot, man, Joe Castello, he's a bullhorn. He makes his living talking, and he's over here learning how to change valve springs on a Pro Stock car. Maybe I could do that too. So I see that as a major line in the sand differentiating factor of what's different today in racing and Pro Stock and in rings and engines than maybe even 10 or 15 years ago, where everything was off limits, and the engine builders out there that are trying to make a living, they were the last guys to ever find out about new technology. Now we're making it so that the stuff that they can put their hands on and know is good is, at the most 6 or 8 months old, not 6 or 8 years old. I think that's where the difference is.
Very exciting, and thank you for watching those bits. It was great to be able to, to touch a Pro Stock car. You can imagine, as a lifelong fan of drag racing and Pro Stock in particular, I never, ever saw myself changing a valve spring, putting together a transmission, putting in a third member, and let alone firing up the car at the end of the year. Those things are all available on the internet, everybody, and I appreciate it. I always like, and Keith, feel free to jump in here, to have our guest give a little final wisdom to the audience out there when it was the engine builders like Jason or Pat What would you say to the young people out there? Keith, let's ask Ben to do the same thing. He's already provided some great initial ideas, concepts for the engine builders out there. But how about it, Ben? Final piece of wisdom for the folks out there that are listening.
Yeah, that's an easy one for me, especially for the young guys that are up-and-comers and saying, how do I make it in this field? I will tell you there's one thing that is more important than any other thing out there, and that is relationships. Pick up the phone, go to the trade shows. Heck, man, get in your car and drive over to Total Seal, knock on the door, and go in there and sit and make a relationship with somebody that you are going to need as you grow in this industry. And so I have a habit that I've developed over the years where it's like I have a big, long list of contacts and friends and buddies in the industry, and I never want to be the guy that only calls Keith when I'm in trouble and I need something overnighted tomorrow. Sometimes I just want to stop in when I'm in Phoenix and say hello and say, you know what, I was thinking about you. Call, my cam guy, my cylinder head guy, and just say, how's things going? How's the wife and kids? Build relationships so that later on, when Keith has that brand new technology ring, he's like, man, who do I want to tell about this? He's going to be thinking about you because he has a relationship with you. And that exists in every aspect of business, but especially in this racing community where things change quick and products happen. If you want wisdom and advice from an old guy up that's, how do I stay around a long time? Answer is build relationships.
Keith, amen, brother.
Keith, do you agree that they should all come to your door and wait for you?
They should. If you happen to be here in town, and I say this, we give tours every day of this place, and that's the honest truth. If you're in Phoenix, you're interested in learning something about piston rings, you want to see how some of this stuff's made, how it's done, please give us a call. Set up a time, come on by. We'd love to show you because as Ben said, this is all about relationships. And I said this in a previous podcast, for the young guys, go out there, go walk down to your local race guy, go down to your local machine shop, introduce yourself, say, hey, you know what? I've got afternoons off. Would you like me to sweep your floor? In exchange, teach me what you know. This is how so many of us learned, and it seems to be a disconnect there today. I'm very fortunate, here in Phoenix. I went to a place called Paradise Valley High School, which had one of the most incredible vocational departments from engine building, car repair, body work, electrical, electronics, woodworking, welding. I took everything I could get my hands on, and that's so hard to find today. But you know what? There's a ton of shops out there, and here's one of the things that I hear every day is they can't find any help. They can't find anybody that wants to come work for them. Well, trust me, there's a lot of guys out there that want to do this and want to get involved with this industry. So like Ben said, build that relationship. Go to your local guy. Say, hey, I'd love to come in here and learn what you know. And you know what? I guarantee you they're willing to teach you, and they'd love to share that information. We have the obligation as the old guard to share what we know and to pass it on. Otherwise, this is going to die, and we don't want this to die. We've got to get this information to the next generation.
Well, and typically sales guys are passionate. They want to meet new people. They want to talk about their new stuff. They want to sell new stuff. And so whether it's Keith at the ring shop or whether it's the head guy or the block guy or the piston guy or whatever, pick up the phone, send an email, build those relationships now so they're there when you need them later. That's what I tell every kid that comes through the school.
Ben Strader from EFI
Absolutely.
University, thank you so much for joining us on this edition of Hidden Horsepower. Keith Jones, great
job.
job.
To be here.
Oh, my goodness, you have done such a great thing on this, the conversation. I told the guys at the start of the show, talk way over my head, and you did, but you're increasing my knowledge base. Ben, thank you very much. Thank you for joining us on Hidden Horsepower.
You're welcome. See you guys.
And Keith,
thanks, Ben.
Another episode in the books. Keith, another episode. This one was a little different, but I learned a lot of information, and I got to say, I was very entertained just hearing you guys kind of go back and forth about some of the what is possible.
The whole point of these podcasts, again, we are a piston ring company, and we want to talk about rings and ring technology. But you know what? It's all a package. The piston, the ring, the cylinder, the head, the manifold, it all works together. And just love dealing with guys like Ben that dive into every corner of that engine and push it to the extreme limits. And sharing every bit of information that we have and getting that knowledge out there and talking about valve trains and rocker ratios and how we get good stability, all of it. It's all a package, and it's all great information. And that's what this is all about, is getting that information out there.
Keith, thank you very much. He's Keith Jones, the Director of Technical Sales for Total Seal. To find out more information, you can go to TotalSeal.com. Remember, subscribe on Apple Podcasts, Spotify, wherever you get your podcast. Hidden Horsepower by Total Seal. More episodes upcoming. Big thanks to Ben Strader and, of course, Keith Jones. I'm Joe Castello. We'll see you next time.